Hi, welcome to Data Heads Academy. This is session 5 in the PowerBI series. In this session, we are going to talk about data modeling. Data modeling is the heart of Power BI. So, it's going to define how accurate your results should be. It's going to define all the calculations. So, we are going to start data model today, and we will be doing 2 or 3 videos in this series. So, this is the first one. So we start with what is data modeling and its importance. We will walk through different components of data modeling like relationships, cardinality, cross filtering. We will talk about dimension tables, fact tables, and calculated tables. And we'll talk about referential integrity. And then we'll compare, create calculated columns versus measures. And we will talk about virtual blank and many to many. We will introduce many to many and we will continue this in our next session. Okay, so being that said, let's start with the data modeling. Okay, what is data modeling? Before that, let me tell you a story. Let's say you are organizing a huge birthday party in an old farmhouse at the city outskirts. You invited lots of guests, right? So your birthday party, you invited lots of guests, and in a farmhouse. You are organizing it in a farmhouse. It's a old farmhouse. And to make the party successful, you have to take few steps. You first go to farmhouse and clear all the space, right? If there is unnecessary material, you have to throw it out. And you also took some precautions and you arranged a different entry and exit point for guests. Okay, so and you took all the guest preferences like veg or non-veg. Okay, so kind of you took all the guest preferences and you also arrange the seating. You modified the place, you arrange some seating and you arrange some entertainment and you modified that place and arrange some entertainment for the guests. And you also plan for some additional guests, right? You also plan for some extra guests. Few people may come with family, few people may come with friends, right? So you took all these steps to make the party successful. Once you take all these steps, right, so the guest comes smoothly, they enter from one exit point and they come from one entry point, they exit from other point, right? And they come, they get entertained, they have their preferred meal and they enjoy the party and they will exit. By taking all these steps, you ensure the party is successful, right? That's the story. Let's move a bit to our role model, which we built in our last session. Okay, if you remember, this is one of the model that we built in our early session, right? So what did we do? We brought in all the data, if you remember. So we modified the data, right? So we have done few transformations on this data. If you remember, we unpivoted this and make a single column. We just splitted the delimiter and all. So we trimmed the data, we modified the data, and then we create a relationship between the tables, right? This is the relationships. We created the relationships. And then we have written few calculations like total sales, right? We have written a calculation and we built a visuals and we publish this report to Power BI service, which is here, this one, DHS sales report, right? This is what we did in our early session. If you notice it, when we publish a report, it's split into two things. One is a report layer where you see all your visuals. The other one is a data layer. If you look at the name, it says semantic model, right? Which means this is a model. Whatever the efforts that you take to build this model or this dataset is called modeling. From the beginning, like from getting the data, you did transformations you establish the relationship between them, and you define the content flow, right? You write the calculations, everything is model. According to me, whatever it takes to you to build this data set is modeling. And let's correlate what we have done, what we have written, right? So, like your birthday party example, if you correlate your birthday party to building a report, okay, and your guess to users, your farmers to data source, clearing this, you are filtering some data, your data cleansing, okay, you entry exit point, right? You established a relationship, so I mean people should come from this side and go that side, right? You data moment. So guest preferences, you can create calculated columns versus measures, and you do some transformations, right? Like we unpivoted some data, so you arranged the seating and all, you modified that place. You plan for some extra guests, right? So even in your model, you should plan for some scalability. It should sustain for long period, right? If you correlate your birthday party example to a Power BI report to build, like how you took steps to organize your party, you took all these steps to throw a good party, right? So you need to do all these to build a quick, great report. So what you have to cleanse the data, you have to build the relationships, you need to write the calculations, and you need to plan for scalability. All these things are model. As I said, whatever you do from transformations to writing measures, whatever you do, everything is data model according to you. Okay. And okay, so this is what data modeling, and what does it make? What is a good model? What is a bad model? How do you judge that, right? So a good model is something which should support all type of calculations, and it should not only support the calculations, it should give the accurate results as well. If it gives inaccurate results, there's no use of building this model, right? If it throws inaccurate results. And the performance, it should be extremely well performed. If your report is slow, then there is no point of building it, right? So you should be careful in building this. And your report should be simple, it should be flexible, and easy maintenance. So if your reports have these four, then you can consider it as a good model. Okay, according to me, if you these are the top four priorities for me to differentiate a bad model versus a good model. Okay, and what are different types of model? What are different types of models available? If you remember in one of our earlier session, in the very first session, I think, different types of models. We discussed about star schema and we discussed snowflake schema. Snowflake schema is one type of model. Don't confuse with the snowflake source, right? Snowflake is a cloud data source. Don't confuse. This is different and this is different. Snowflake source is a different. That's a cloud warehouse. This is snowflake schema. What does this mean? Let's recap it quickly. So if you have a central fact table which is directly connected to your dimension tables is called star schema. And if you have a fact table and if there are some dimension tables which are not directly connected to fact tables, right? They are indirectly connected. This is called snowflake schema. And you can see here the examples. Here, the location table is directly connected with the sales table. In the second one, in this one, your location connected with this and your city dimension table is indirectly connected to the fact table. There's no direct connection. These kind of models are called snowflake schema models. These are called star schema models where each dimension is connected to fact table directly. Okay, this is good. So what is the difference uh, why do we don't go to star schema, snowflake schema? This is basically the dimension modeling, right? Hey, you build the dimensions. These are the dimensions. You build the fact table. So this is the dimension modeling where you build a model into facts and dimensions. What happens if you maintain a single table? So what is the problem? If we Why do we need to maintain multiple tables, right? So let's see that. Let me open a report. Okay, before that, we'll see few differences. Why do we need modeling? We need dimensional modeling. And to tell one, I mean, I forgot to tell one thing. So Power BI is highly optimized for star schema. Why is that? We'll see in our further sessions. But let's keep that in mind. So why do we need dimensional modeling? I'll give you. There are lots of reasons why do we need to choose dimensional modeling over a single table. Out of them, first one is like updating details. It could be warehouse level, it could be in report, wherever, right? So if you follow dimensional modeling, it is very easy to update a one record. We'll see it in a demo. So let me give you other three. It takes more time to scan the tables in single fact table. And third one, it is difficult to write calculations on single table. So let's see them. Let's see them in demo. The first one is it's very difficult to update the details. Let's say I have built a model. If I go to, if you see this report, so I have built two things. One is a direct single table. If you see this sheet one, right, is the single table model. Let me rename it. If you see, everything is there part of one table. The sales ID is here, the customer ID and the customer name, mobile number, and address, product name, everything is here, right? Suppose if I want to update my customer name, let's say if I want to update and Ami's name, Ami's mobile number. So if I have to update, I have to update in all these records, right? If I maintain a single fact table, I have to update so many places. It could be few today. It could be one or four today. Tomorrow it could, if it is a long customer, right? If it is a old customer, there could be thousands of rows. If you have to update the mobile number, you need to update everywhere. Look at the other model which I built with the same table. So if you see it here, we made it a dimensional modeling, one to many, star schema model. If I need to change the mobile number here, right? I don't need to change in all the fact tables. I can just directly go to the customer table. If you see the customer table, let's filter Ami Garden. That's it. I can just simply say change the number here. With a single change, it will be replicated. And there is a relationship between customer ID and fact table, so I can access this number anytime. I don't need to change it in multiple places. if I follow the dimensional modeling, right? That's one advantage. And the next one is table scans. Let me show you. Before we go that, uh, we discussed about these ribbons, few of the items in few of the options available here, right? We skipped few. So let's discuss one of such option. If you see this one, performance analyzer in view section, if you click that, it will open a new pane here where you can analyze the performance of all your visuals, your DAX calculations. If someone complains you the visual is failing, if someone complains you the report is, I mean the visual is very slow, loading very slow, this is the first place where you need to come and look at. Here you get all the stats, how much time the DAX query is taking and all. Let's build a quick two quick uh, slicers. Let's go with the slicers just to check the performance. The first one, I take it from customers table and name. I'll name it as dimension modeling. Copy paste. I'll create one more slicer. Here I'll use the same field from a single fact table. If you see here, what is the name? Okay, so and let's give a proper title, single table model. Okay, let's see the performance analyze. If I select something on the dimension modeling table, if I select something on the dimension model table, let me select Amigarden. Let me start recording. When we start recording, it will start capturing all the stats. Let me select Amigarden. You see the dimension modeling, right? It took 75 seconds, not seconds, it's a milliseconds. 75 milliseconds to get this results, to select this value, right? Let me clear it and check the same here. If you see here, this one took 91 seconds. Earlier, this model took 74 seconds. This one took 91 seconds, right? So it takes some more time. Why? Because if you a single model, if it is a single model, if I go to the single table, it has to scan all these 10,000 rows to get the distinct customer names, right? Whereas if you follow the dimensional modeling, it gets directly from the customer name, which has only 100 rows. Obviously, right? So all the dimension tables will have less rows. Fact table will have more rows, correct? So that's one reason. Right now there are only 10,000 rows and the names are very repetitive. But if assume in real-time scenarios where there are millions of rows, if it has to scan millions of rows for every slicer or every filter, in real time there could be multiple slicers, right? Every slicer will take time because it has to get the districts, right? So it will take more time and it impacts your report. That's one of the reasons. And the third one is difficult to write calculations, right? So if you have, there is a concept called context. So filter context, row context and all. Sometimes it becomes difficult to write the calculations on a single fact table. We will see these examples more in our DAX session, but remember this, so single fact table is difficult to write calculations. It's very difficult to manipulate your dimensions. Okay, so these are the three primary reasons, three main reasons why you need to go for a data model. Okay, now we have discussed what is data model, what is a good data model, and why do we need to do the data model, right? Let's discuss the components of data model. How do you do data modeling, right? So before we begin that, in this section, First, we will talk about the tables in any data model, right, or in any Power BI report. First, you will be having tables. There'll be different tables like a dimension tables. There'll be fact tables. There'll be some calculated tables. We will see more calculated tables and all in DAX sessions. And next one, you will create a relationships between these entities, whatever you did, right? All between all the tables. What do you have? You have types, different types of relationships like active, inactive, and then you have cardinality. And cardinality defines how they connect. Are they one to many to many? How they connect. And then cross filter direction. And there is a concept called referential integrity. And with this, I will cover a section called virtual blanks. How we defaultly add one virtual blank. We will talk more about that. And then we will go for calculated columns versus measures. And then we will finally talk about many to many relationship. I'll introduce the just introduction. Many to many are like a kind of complicated relationships in Power BI, and you should understand them to build a good report, right? You need to understand the nature. It's not a troubled relationship, but you need to be aware of few facts so that you can avoid the mistakes. You can avoid the ambiguity, right? So these are the things that we are gonna talk. And to start with the tables, so I have read one book called Analyzing Data with Power BI, written by Alberto Ferrari and Mark Russo. It's a beautiful book. I'll give the description for that book in the link. In description, I'll give the link for the book as well. So they say in their book they mention two things: assets and facts. All the business assets like customers, right? All the dimensions they call it as assets like customers, employees, right? Working days, or product. So these are different assets, and it varies from business to business, right? And they also say when the assets interact with each other, when the assets interact, generates a fact. For example, employee A sold 4 kgs of rice to customer B, right? So these are the interactions of assets like A employee is an asset, right? And 4 kgs of rice is a quantity, which is a fact. And rice is a product, and B is a customer. Product is an asset. Customer is an asset. When these assets interact with each other, they generate the facts. What are the facts here? How many quantity, which is what product I need, right? This is the fact. And the price. When you multiply quantity by price, it gives you the amount, which is a fact, right? So to just differentiate between dimensions and facts, dimensions are your assets for your business, and facts are the ones which gets generated when your assets interact with each other. Okay, and we have already talked in detail about dimensions and facts in our first session, right? So, and we will be doing that in further sessions. And there's one thing. that we never covered is a calculated table. These tables, dimensions and facts, mostly you get it from the warehouse, right? Then sometimes you would need to create few calculated columns. Not columns, not tables as well. It could be for security, or it could be for some data manipulation, or for some staging, for some advanced calculations, right? Instead of using heavy DAX, you would push that to the data model, either through calculated column or calculated tables and all. So calculated for now, just remember that calculated table is a table that you calculate it out of the data you have, out of the dims and facts. It could be an aggregate table. If you discuss one aggregate table, right, you can derive an aggregate table as a calculated table. Thus about tables, let's talk about the relationships. Before we talk about relationships, let's switch back to our Power BI report and see. This is the data model I have prepared. Whenever you get the tables, right? This is a fact table. This is the dimension tables which we were speaking, right? This is the dimension table. This is the dimension table. And relationships. Uh, if I want to derive relationships are the connection between two tables. That relationship basically defines the relationship between two tables, how two tables are connecting. It defines that, right? So if we want to create relationships, we'll just need to mention the table names and the cardinality. I'll come to the cardinality and cross filter direction. How to filter, which in which direction these needs to be filtered, right? And yeah, and you see this assume referential integrity, we'll talk about that. And we will make active and inactive. There are two types. If you take the relationship, either you can make it active or inactive. If you put them inactive, it's not going to work. You can still activate this in calculation level by using some functions, but by default it will not filter. Let's see an example. Let's go to one table. Let me put a slicer from product table, product ID. I'll make it a vertical list. Okay, and let me add one more slicer from sales table. Maybe let me add a card visual, or maybe add store ID. Yeah, let me add a simple fact. Okay, I have added the sum of quantity. If I select product, it is not filtering the quantity because there is no relationship between them. There is a relationship, but it is in active stage, so it's not going to work, right? You are filtering the product, but the sales is not getting filtered because this relationship is inactive, right? I select anything, it's not going to filter. Let's make it active. When we do that, now see, all the product is going to filter this, right? Now from sales table, let me take one more event or sales ID. Let me create a slicer with this. If I select product one, it will filter all the sales IDs. Vice versa, like if I filter product ID, it's not filtering any product. Okay, let me give it a both directions. Right now you see, if I filter sales ID, it will be filtering the product ID as well. Why? Earlier, the data movement was in one direction, right? So it was like from product table to dim table. It was from product table to sales table. So product table was able to filter sales table because the data movement is in this way. This is a cross filter direction. This defines how your data needs to flow, right? All the data movement will happen from product table to sales table. Here if you see customer table to sales table, store to sales table. Reverse direction, the data movement, the data can't move. And if we edit it, if we make it bidirectional, then data can move in both way. This table can filter this table can this filter this table, right? And even customer table could filter product table, because the customer table filters sales table filter product table, right? If you see that there's a flow, it filters this and this filters this, right? So you need to define the data movement as well based on your scenarios. And yeah, these are the different components in creating a relationship. To create a relationship, you need to select two tables, you need to define the cardinality, you need to define the cross filter direction, you need to select whether it's need to be active or inactive. This one I don't talk now, we will talk in our security section uh, more about this. And assume referential integrity, I'll come in a while. So now if I let's move to the notepad. Okay, so we have seen active inactive relationships. We have seen the cardinality. Cardinality basically defines how your data is connected. Like there could be one to many. There are different cardinalities, like one to many to one to one, and many to many. So one to many, for every one record in your dimension table, there will be multiple records in fact table, right? If you see this example, there is a if you take the customer name is there. If you see 100 rows and 100 distinct customers, right? For every customer, if you go to sales, there's a multiple references, right? Customer ID, if you see the customer ID, there are 100 distinct values but 10,000 rows, right? Every customer could purchase multiple times, right? So you will be having multiple records. These kind of things are one to many. And many to one is simple, it's a reverse. If you see from this side, dimension side, it will be one to many. If you see from the other way, it's many to one. There's no much difference between them. One to one, you will be seeing one to one relationship in such cases, but this is a stale relationship. Like we can merge into one when there is a relationship between, let's say, you have table, you have product or price. Every product will have only one price, right? You can merge them in one table. We'll see in our next session like best practices of merging one when there is one to one. Many to many we'll talk in detail. For each record in a dimension table, there'll be many records in the fact table as well. So for each record here, you will be having many references here. Let's say for example, if you have one here in table A, even in table B, you'll be having multiple records. Like one record could be there multiple times in both the tables. This is a many to many. We'll go in detail about many to many as well. So that's about the cardinality, and we also discussed the this cross filter direction as well. So whether it needs to be single or multi directional, right? Bidirectional. And let's move to the referential integrity. So this is kind of important. So let's say you have two tables, table one, table two, right? For every table, let's say in table one you have four records. In table you have multiple records. For every row in table one, if there is a that reference in table B, right? This is one scenario. Let's add few more values called in table 2. For these table 5, there are no references in table 1, right? For all these four values, there is some reference in other table, but for this one, there is no reference in other table, right? Basically, referential integrity defines the accuracy and consistency of a relationship between two tables. If there is a relationship between these tables, let's say one to many, referential integrity is to check the accuracy. Does every record here has a reference in this table or not? Right? And it should check the consistency for all the records. Right? So to just define it in a one line, referential integrity is to check the accuracy and consistency of relationship between two tables. Why this is important? Let's do an example. Let's say I want to visualize this report. If I get the from table 1, if I get this column 1, 2, 3, 4, if I get the count from table 2 counts, right? For 1, there is a 3 count. For 2, there is a 2. For 3, there is only one record, 1. For 4, there are 2. There are other records called, there are 3 other records which are 5, but there is no reference here. How come they need to show, right? If you look at the total number of lines in table 2, total number will be 11. But here if you look at this, it is only 8, right? 3 rows are missing. For that, Power BI adds a virtual blank here. In one-to-many relationship, whenever there is a when the referential integrity is missing, for all the missing values, it adds a virtual blank and shows that number 3. If there are other records like a 7, 7, if there doesn't have reference here, it will take that count and it will show as a 5. These count will show that. Power BI by default adds a blank value when you are visualizing one to many and when the referential integrity is missing. Let's see that in a demo. And before I go into this, I just want to recap one of the concept. So we have seen different modes, right? We have seen import mode, different connectivity modes, direct query mode, live connection. Live connection is for analysis services. You can't do anything. You just build, you connect to the model, right? And import mode versus direct query mode. For import mode, all the responsibility because you get all the data into Power BI, and for all the calculations, Power BI is responsible. Which language it use? It use the DAX language, right? In direct query, source is responsible, right? If you are doing import mode reports, Power BI assumes the referential integrity, and adds a blank value, blank in one-to-many relationship. In direct query, it is source responsibility. Let's say you have two reports. One is import mode. Import mode, you have Excel reports, Excel sheets or something. In direct query, you have a Azure SQL database. Okay. For import, and if the for all the one-to-many relationships, Power BI assumes the referential integrity. In direct query mode, it is to be by it is the source responsibility, but Power BI frames the query, right? Based on the visuals we build, it has to send that query back to source and source has to execute that. Let's see that in demo. Okay, so let's see all this in a demo. So I have two models now. If you see here, if you see the title, I have import. There's the import mode, and I built the same report in a direct query as well. If you see this is a direct query report. So it connects to Azure SQL, same data model, everything same. Now let's see the difference. Okay, let me close this. Okay, now we have two reports. One is import mode and the other one is a direct query. You can just look at the headings. DQ is stands for direct query, and same model in both the report. Okay, let me make it to single. Let me build a visual. I'll build a table visual from sales. I'll get the sales ID. I'll do the counter of sales, maybe by product name. And this is the visual I built. Let me build the same visual in direct query as well. Okay. So this is a direct query mode report. We don't have the data, we just have the metadata. We can just see the table names and column names in direct query, and we can't see the data view, unlike import mode report. Import mode, we can see the data as well, right? And if you see the number, it's same because it's the same data set. One is in import, one is in a direct query. Now, let's go to the performance analyzer and see the query. So I'll start recording again. I'll refresh the visual and you see it here, right? So it's taking how much time to execute each query, and this is the query which generated this results. Let me copy that, right? Import and paste it here. You see, right? It's a DAX query. It is using DAX report, DAX language to build the visual. It's writing all the calculation in DAX, right? It's right, this one writing all the calculation in DAX. Let's do the same in here. So view, performance analyzer, start recording, let's refresh, give the query, let me copy it. This is a direct query. If you see here, the direct query, it is writing a SQL query. It is taking top 1 million and product name, sales ID, and it's doing a left outer join, right? And it on product table it's doing a left outer join and giving the results. So this is framing this query and sending back to the source is Azure SQL. This query executes over there and gives us the results. Everything is fine, right? And what join it is doing? Left outer join. Why? Because if we go to the relationship for this table, product and fact sales, right? Here, when we created one to many, we didn't assume the referential integrity, right? It can't scan all the records, so it doesn't assume by default. So it assumes that Power BI assumes that there are few records that are missing from fact table, like this. So it assumes that there could be some values that would be missing from fact table in dimension table, right? If you are sure that every record in dimension table has a reference in fact table, you no need to do a left outer join. What does left outer join do? Let's say if it is a table A and if it's a table B, which is a fact dimension, inner join will bring the common records left outer join does two steps. One, it brings the common records, and second one, it brings the non-matching records, right? So this does inner join does only one operation. Left join has to do left outer join or left join has to do two operations. So it definitely takes more time to do a left outer join compared to inner join. If you are sure that your data is proper, you have the referential integrity in your data, you can enforce that. Let me enforce that. Let me assume the referential integrity. It just quickly validates and let me save it. Now, if I go back, let me clear everything, refresh the visuals, expand the table. Let me copy the query now. And if I go to here and new window, if I put the query here, you see inner join. Now, all the joins are sending to Azure SQL as the inner joins instead of left out joins. Why? Because we assume the referential integrity. We enforce the referential integrity, so everything will be sent as a inner join. That's one thing you need to be aware, like how to enforce referential integrity in direct query. And if you see in import mode, you don't have it. You don't have that option to enable. Let me take the product between sales. Let's say I edit the same relationship. This is inactive because Power BI automatically assumes the referential integrity when it's in import. Because Power BI has everything, it can does the calculations, right? DAX does the calculations in local. So by default in import mode, it assumes the referential integrity. Whereas in direct query, where the operations are dependent on the source, it enables, it gives you option whether to assume the referential integrity or not. So I hope everyone understand what is referential integrity. And let's see the example of adding a blank value, right? For that, I'll create two simple tables. Let's say table one. Okay, I'll manually input the data. One, two, three, four. I think I was explaining on the wrong window. Let me explain you again. So let me explain again. Okay. In direct query mode, uh, now you can see, right? So in direct query mode, there is an option to enable the referential integrity. Earlier we saw the left outer join, right? When we disable this, it was disabled and we saw left outer join. When I enable it, it takes the referential integrity in account. And if I go to visual, performance analyzer, clear it, if I refresh the visuals and expand the table, copy the query, now you see inner join. When I assume the referential integrity, it is taking inner join because in direct query, it we Power BI just frames the query and source has to execute the query, right? How do you send whether left outer join or inner join? You can control it from here based on the referential integrity, right? From here. Okay. If I disable that again, if I disable referential integrity and if I go back and clear, refresh, right? The left outer join. So if you assume the referential integrity, and it will do inner join and your query performs better. If you don't assume, it does a left outer join, which could take more time based on the data size, better data volume and all. And this option, this referential integrity option, is available only in direct query modes. Let's switch to import mode and see that. So let's take the same relationship, product and sales relationship, and if we go here, there's a many to one, same, okay, but the referential integrity is missing. Why? In import mode report, Power BI is responsible for handling all the data, right? Because the data is available in local. Power BI automatically assumes referential integrity. You no need to do that. To do that, I have created a simple table now, which is called table 1, which has 4 records. This session I'll go with all the lemon examples, and in next session we'll talk about all the business examples. Like we'll take actual scenarios and interpret them. Now in table 1 you have 1, 2, 3, 4, just distinct records. Let me create a new table, table 2 or many. Let me create multiple references for each one. 3, 4, 4, and 5 is missing, right? There 5. I'll create 5, few 6s as well. Okay. Now let me load it. I'll create a relationship between these two, and this is one to many, which makes sense, right? For one record in table 1, there's a multiple references in table 2. Okay, let's visualize that. I'll stop the performance analyzer and let's visualize in a table. I'll take the column 1 from table 1, and from many side table I'll take the counts. Let me count them. Now you see you have 12 records, and 1, 2, 3, 4, there are 3, 2, 1 and 2 references. If you see this, for 1, 2, 3, 4, there are multiple references. For 1 there is 3, for 2 there is 2, for 3, 1, 4 there are 2. 5 and 6, there is no reference in a column 1, right, in table 1. So Power BI by default maps them to a blank value. If you see here, it created a blank and it added all the 4 values which have no reference in dimension tables and mapped with a blank. This is referential integrity. So you no need to enforce referential integrity in import mode. Power BI assumes and it will add a virtual blank on the dimension tables for all the missing values. Okay, this one. Let's make it a many to many and see what happens. So same table, table 1, edit query. I'll add one more 1 and 2 to make it many to many. There are many values for 1, 1, 1, and on the opposite side table there are 3 ones, right? So let's make it many to many. It doesn't take, so let me create a new table instead of creating that. So let me call table 1 many. We go with the same one, 1, 2, 3, 4, 1, 1, 2. Let's load that. And if we give the relationship between these two, and if we give relationship between these two, this will be many to many, right? It gives you a prompt like what is it, and you can click here and learn more about many to many. Let's create it directly. Let's not discuss now, and we'll discuss more about many to many, the scenarios and all. It's got changes. Now, let's visualize table 1 many to table 2 many. Okay. I'll take the same table 2 columns and right. Now if you see in table 1, one many, which is a dimension table again, it has a distinct, but it has many values. For every reference, there are many references. For one in table 2, there are multiple references, right? So if you see the relationship, this is a many to many. Now see the behavior. If you look at this versus this is a one to many, and this is many to many. In many to many, it is not adding a virtual blank, right? You see only the counts. So let me check the counts. Yep. Now, if you see, it is saying count is 12, but if you count them 3, 2, 5, 1, 6, and 8, it is giving 8 count, but in total it is giving 12. And if you go to the column and count the totals, if you count it here, you see, right, 12 rows. There are 12 rows here. But in actual value, it is showing only 8. 4 are missing. What are those 4? If you see here, 5, 6 has no reference in many side, this side. 5, 6 are missing. So in many to many, it can't assume the referential integrity. It can't handle that, right? That's why the totals are different from the actual numbers. This is one thing you should be aware of. This is one important thing that you need to be aware of, right? So uh, that's a behavior of many to many. I don't say it's a bug or what or not, but it's a behavior. That's the behavior of many to many, and we'll talk more in detail about many to many in our next session. Okay, and these are the basic differences. Like referential integrity, we have seen what is referential integrity. It checks the accuracy and consistency between relationships be- of relationship between two tables. And Power, in import mode, in one-to-many relationships, PowerBI by default assumes a referential integrity and it adds a virtual blank like this. In many-to-many, it can't assume referential integrity, so you don't see the blanks. That's why the totals are different from the actual numbers. And direct query mode, you can enforce the uh, referential integrity, and you can make it when the referential integrity is there. All the SQL queries that goes back to the source, it goes as an inner query, inner join. When the referential integrity is not assumed, we have to enforce it externally. It can't assume by default, right? And if there is no, if we don't check this option, everything will go as a left outer join or left join. And when we check this, it will go as a inner join back to the source, right? Inner join performs better than the left outer join. So these are the things about referential integrity and adding virtual blank on the dimension tables. Now the last one, so we have a calculated columns and measures, right? So far in a model, there are different tables, dimension tables, fact tables, relationship, cardinality, and filter direction. We have spoken about, we have discussed everything. Now the only pending thing and is a calculated columns and measures. Let's see that. So calculated columns, the name itself tells you, right? Calculating some columns, calculating some additional columns. Let's go to the direct import mode report. If we go to the sales table, now I have the quantity, right? I don't have price here. So I'll be deriving the price. If I want the total amount, I need to do the quantity multiplied by price, right? So in any business, right? So let's say you have a sold for quantity, you have sold 4 kgs, right? And if the price is 15 rupees, you need to multiply this to get the total sales value, right? Sales value, sales amount. To get 60, you need to multiply by quantity by price. But if you look at the sales table, there is only quantity, but there is no price. But the price is in a product table. If you go to product table, There's a price for every product, and there is a relationship between product and sales. So we can get the product price to sales table. So sales table, I'll write a new column, price equal to related of price from which table? Product table. Why am I writing related? Don't worry about this. We will discuss in our DAX sessions. And what do we need? We need the total amount, right? Total amount equal to price multiplied by quantity. Now I got it, right? I got the total amount. I can visualize now. If I create a card visual and if I add my total amount, it gives me the total amount of my sales. Now this is one way. This is a I created few columns, additional columns, right? I created a price column. I created a calculated this column. I calculated with the quantity and price, right? These are the columns I created and I calculated, right? I calculated this with the logic. The same thing we can do in a measure as well. Let me create a new measure. Total sales measure. Okay, sum x of sales table. Don't worry about this calculation. It's a very simple calculation. I'll explain it in our DAX session. So quantity from sales table and price from product table. You see the difference? The total amount, it's a calculated table. That's why you see the sum and one column symbol, right? If you notice the symbol, this is the symbol for calculated tables. If you see quantity, sales, store ID, product ID, they don't have this symbol. Only price and total amount has this symbol because they are not, they didn't come from source. We externally created them. We calculated them, right? Those are the calculated columns. And if you look at the measure has a calculator symbol, right? This is the reference for measure. And let's visualize the same measure, card visual and total sales. Why it's different? Give me a second. Did I filter something or okay? Give me a second. Let me figure out what's the issue. Sales quantity into price. The same here. Are there any blanks? No blanks, nothing. For some reason, it's giving a different value. We'll come to that. But ideally, it should give the same. Uh, Sales price, quantity, the any miss in the relationship. I don't know what's the issue, but we'll come back to that. Okay, ideally it should give you. So we can do in both the ways. One is a calculating measure, one is a calculating column. I don't know what's the mistake, but I'll figure it out at the end. And if you go to the Power Query, right, I mean direct query, right? Here you don't have the option of creating a new table. You don't have the option, right? You have to definitely create a measure. You can't create a calculated columns because you don't have the data, right? You can't derive a new column here. Here you definitely have to create measure. In fact, you can create calculated columns only in import mode reports. In direct query or live connection, you have to go with the measure. There is no other option. So let's create the same measure here. So if I create a measure, total sales, same formula sum x on sales, fact sales. We take the quantity and price from enter. Now you got the measure, right? You don't have calculated columns. You can't create calculated columns, right? That's the limitation. And if I visualize 52.48, right? That's my sales value which is coming up. So let's look at the differences, few more differences between calculated columns and tables. So if you take the calculated columns, so they compute during the load time, right? So if you want to refresh your report, everything is loaded, and on top of that, these two needs to be calculated. Okay, for that it would take some time, right? Because it needs to be calculated. It needs to perform additional steps on top of the existing data, right? So when you refresh it, at the time of refresh, it loads this data, it refreshes this data, and it will be calculated. It will definitely take more time, right? And so this one, yeah, I was referring this one. For these two, you calculate them, right? So it will definitely take more time. When you refresh, this data gets all the static data, all the data from source gets refreshed. On top of this, these new calculated columns are computed. So it will take more time. So these are computed during the data load, and it stores in the model, right? It will compute and stores in the model, and it will not further calculated. Measures, whenever measures, right? They computed on the fly. If you create measures, it will not be calculated at the time of refresh. This measure it will not be calculated unless you use in a visual. If you use in such visuals, then only it will be calculated. If I don't use this measure anywhere in my report, it will not be calculated. So when I use this, then only it gets calculated, right? And usage, right? When we go for calculated columns, when we have to create a row by row calculations, now we have seen, right? We have calculated the total amount by each row. And if you want to add a new columns, like sometimes it could be conditional columns as well. Like if you want to categorize, let's say you have few products, right? And you want to categorize them. In category 1 you want to add A, B, C. You want to add in category 1 D, and E. You want to add category 2. You can write some condition. If product in A, B, C, then 1, right? You write these kind of conditions and create a calculated column, right? So, and aggregations, if you want to add the aggregations, right, then you go for, if you want to summarize your data or aggregate your data, you will go for the measure. And storage. So calculated column takes the physical space, right? It's creating new data in your model. So it will occupy more space. Calculate measures doesn't take any space because they are calculated on the fly. It's just a formula, right? It just take the compute engine. It takes your processing capacity and just process the data and calculate that column. Okay, and performance. If you if you come to calculate columns, it will take the more space, right? So it will take more storage, right? So it will increase your data set. For small data set, it's fine. You don't see any impact. For big data sets, it will have a huge impact, right? And and yeah, coming to the measures, they're typically fast. I mean, if you take at the query time, it will be fast because it will calculate on the fly. It won't take any space. When you refresh it measures are not calculated, so it will be fast. So context, it's a calculate by row. Okay, calculations happens for each row, right? Whereas measures, you can filter them, right? And if you want to enforce the calculation at a row level, you can still enforce that. Okay, and there are few DAX functions which we can discuss in our DAX session, but you can, these are the few functions. There's a context which will go in detail on that. These are the few functions. And scalability, less scalable for large resources because it occupies the space, right? So you can't scale it further. If you have a 100 million fact table, if you have to create 2 columns or 3 columns, right? By creating every column, you increase the space, you increase the storage, right? So for those kind of data sets, just go for measures. Okay. And dependent on the model schema, right? So if there is any change in the model schema, it fails. The table fails, right? It can't refresh. Even the refresh fails. If there is a calculation column on some x table, suppose there is a column called x, I derived a column on based of this x, right? If I delete this x, the refresh will stop, right? Because there is no, it can't compute the y, it can't refresh the y, so the refresh fails. And measures, it won't happen because at the time of refresh, it doesn't care about the measures, right? It don't evaluate the measures. It just evaluates when we use in a visuals. That visual where this y field is there or this measure is used, it will fail, but the refresh will not fail. Okay. And update frequency, it updates when we create the model, when we refresh the model. When we refresh the model, it will create once and be fast from there on. And this one, it will be evaluated whenever we drag into a refresh in a visual. If we put it in a two visuals, it will be evaluated twice based on the other attributes in that visual. Okay, and where do you go with the calculated columns, like strings and strings? You can't aggregate them, right? So, and all the facts you can go with the measures. And this is one example for writing calculated columns. So we have seen that, right? We have seen in our examples as well. Okay, and model refresh or impact. Since it is calculated at the time of refresh, that refresh time will be increases, right? It will increase the refresh time and it will take more storage. So it also increases the refresh time because it has to do some additional calculations on top of the existing one. And if we look at these measures, this will have minimal impact because they're not stored, right? It doesn't affect the refresh time at all. It will take some additional resource to compute, but it will not take it will not take the storage. Okay, and visibility, you can see them in data view and report view because you are physically creating them, right? So you can see them in data view. This one you can only see in report view because you didn't add any data for that. It calculates on the fly, right? So hardware resource consumption, when you create a calculated column, as we discussed multiple times, like a storage, it will take more storage, right? High storage. And on the other hand, CPU CPU resource will be consumed more at the time of measures because it has to calculate on the fly, right? Whereas if you come to import, I mean calculated column, it's pre-computed storage. It's just to perform on the physical data, whereas it has to calculate things on the fly. So it will take more CPU usage. It will and connectivity mode. It will only calculated columns can be created only in import mode, and this one measures can be used anywhere. Import direct query live connection. Okay, this is the broad differences between calculated column and measures and when to use what. So if you have a three scenarios like if you have row level calculations or if you want to enrich the filters, some sometimes you want to create a filter like I said, let's say you want to use a product category. Okay, let's say you have some products, let's say products A B C D E, right? And price 100, 200, 300, maybe 1000, 2000. If you want to categorize all the products more than 1000 as a high, you would need a calculated column, price range or something. So if it is less than 1000, I'll create a low. This is a calculated column, low. This is high, high. And this one you can use in a slicer. You can put this in a slicer and it will have two values, low and high. Based on that, it will filter these, right? If you want to derive a new column and add it in a slicer, you can't do it with the measure. You can only do with the calculated column. Then go for calculated column. If you want to filter or derive something and filter, go for calculated column. And if you have any static calculations that doesn't repeat and these kind of things which you want to use repetitively, right, just go for that. And when you have aggregations, right, so if you take a calculated column, you can't do them at column level. You can't do them at column level. You can only do that at a row level, right? For every row it has to calculate. Whereas if you want to sum of all the sales value and filter it, right, you can't do that in calculated column. You can do that in a measure dynamically, right? And so dynamic calculations, as I said, so if you want to write any complex calculations or if you want to dynamically if you select something, one value, it should show only certain set of products. If you select B, it should show certain set of products, right? So these kind of manipulation, these kind of dynamic calculations you can see in using a measure, right? And even sometimes you change the titles dynamically. You need to have a measure for that. You can't do that with a calculated column. We will see all this in practical implementation in our DAX sessions. And performance efficiency, as I said, if you more worry about storage, go for measures. If you more worry about the runtime, or if your calculations are taking more time, then leverage calculated columns if storage is not an issue for you. Just a brief comparison about calculated columns and measures. And that's it for this session. And in next session, we will go. So far in this session, we have discussed all the layman examples like one, two, three, and all, right? By giving some random numbers and all. In next session, we will talk about all the business scenarios. And in next session, will be more focused on the business scenarios and different issues that you face while doing the modeling. And also, we will cover the one almost 30 to 40 minutes for calendar table. Calendar table is very, very important because any model or any business, they will be having all the analysis over time, right? How the business is doing over the time. So time is an important factor, date or time or, you know, this is a very important factor. So we will be discussing that in our next session. Yeah. Next, there'll be continuation to this. I'm not sure. It could be either one or two sessions. So yeah, that's it for today's session. And in next session, we'll start with many to many and go with all the advanced scenarios and the regular problems that we face with model. So thank you. I hope you like this session and I'll figure out the issue, what's happened with that data model, and I'll explain the same in our next session. And I hope you like this